practice test 3 at the top. And we are starting number 1. Here we go. How many outfits can I make if I have 10 jumpers, 12 shirts, and 2 pairs of shoes? Does anybody have an idea? What did you say, baby? 10 times 12 times 2. Now you're exactly right. Make sure you can do that on your own. 10 times 12 times 2. Okay, so you write that down, and then you type it into your calculator, and you say 240. That's all that has to be shown. So there's room there for you to squeeze that in. Then you put a circle around the 240, because we're going to circle our answers. All right, number 2. How many ways can 8 people be seated around a bonfire? 7 factorial. Because what's the rule for circles? They're 1 less. So we write down 7 factorial. Then we get out our trusty calculator and we type in 5,040. 7 factorial, and it says 5,040. Kieran, everything okay?
Yeah, I was just getting my iPad plugged in.
Okay. How many ways can you answer 10 multiple choice questions if each question has 3 options? 3 different. Each question has 3 options, and there's 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't have to write out all these blanks, but there's room there for you to do it if you need to. How many options do I have? I'm going to guess at this first question. I have 3. Now I'm going to guess at the next one. I still have 3, right? And 3, and 3. What am I going to do with all those numbers? I'm going to multiply them, aren't I? So what's 3 times 3 times 3 times 3? What is that? 3 to the 10. And then I'll get out my trusty calculator and I'll type that in. And what is 3 raised to the 10th power? 59,000?
Yeah.
49?
Yeah.
Mrs. Ford is
Perfect.
a or a 100.4.
All right, we ready? Okay, so far so good. Number 4. What is the probability of being dealt a 5-card hand that has exactly 4 hearts? Now, we're going to assume this is a standard deck, okay? Even though it doesn't say that, we're not doing anything funky. A regular deck of cards, 5-card hand, exactly 4 hearts. Any ideas? Yep, Troy?
13C4 times 39C4.
Okay, you are exactly right, but we need to talk about that. Make sure everybody else is up to snuff. The denominator in a probability problem always represents the total. How many total cards are there in the deck? 52. How many total cards am I picking? 5. So your denominator is total available, total picked, 52C5. Everything's total in the bottom. Now, the hand I got, I wanted to have 4 hearts, right? How many cards were in my hand, though? 5. So what does that mean? I have exactly 4 hearts, then what else do I have to have? Another card that isn't a heart, right? Because you need 5 altogether. So there are 13 hearts. You're going to pick 4. What's this 39? It's all the rest of the cards. It's the diamonds and the clubs and the spades, right? And you're going to pick 1 of those. Please don't forget this piece of the problem. That card isn't mentioned in the problem. All it talks about is 4 hearts. But remember, it's a 5-card hand. So you still need to pick another card, even though it's not mentioned, right? Okay, so you're gonna type that in on your calculator. You're going to get, you can answer as a fraction or percent or a decimal, I don't care. So 13, C4. In terms of a decimal, I got .0107. Did you? And it doesn't want to make it a fraction for me, so I'll just stick with that. Okay. Number 5, another card problem. What is the probability of being dealt a 5-card hand that has all face cards? Maya?
12C5 divided by 52C5.
Now, Maya, you're exactly right. I think everybody hopefully gets the denominator. But tell me how you got 12C5.
There's 3 face cards, so Jack, King, and a Queen, and then there's 4 different types of, I don't know what to call it.
Suits.
Yeah, suits. So I multiply 3 and 4. And then order doesn't matter. And then you have to have exactly.
Exactly. Beautifully stated. Perfect. Patrick?
Not counting aces and space cards.
Do aces have faces on them?
Aces are never face cards. Aces are never face cards.
There's three face cards per.
There's 4.
There's 3 face cards.
You need to know how to play the game, but you need to be familiar with it.
12C5.
Now, as often happens, this came out in scientific notation. So when I write it down, I can go ahead and write scientific notation. There is not a problem with that. Or you can change it into a standard form decimal. What you can't do is just write down this number. That will be wrong. If there's an E hanging on the end of that, make sure you put it in, write down times 10 to the whatever. All right, so far so good? Number 6. There are 80 seniors in the math room. All of them enjoy matrices and or vectors. If 48 love matrices, 42 love vectors, how many like only vectors? This is going to be a Venn diagram problem. Would you agree with that? Abby thinks it's a Venn diagram problem. I think she's right. Would someone give me a sign of life? Would you agree with that?
Yes.
Okay. So we're going to draw our Venn diagram. And we have matrices and vectors. 48 of them love matrices. 42 of them love vectors. There are 80 altogether in the room. Now, all of them enjoy matrices or vectors. It says that in the problem. What does that tell me? There's nobody out here, right? Everybody's going to be in a circle. So think of it like this. Everybody's voting. There's 80 kids in the room. I say, how many like matrices, how many like vectors? Everybody votes. Because it says everybody likes something, right? So, how many like matrices? 48 hands go up. How many like vectors? 42 hands go up. Oops, there's a problem. How many hands went up? 90. But there's only 80 in the room, so what does that tell me? 10 kids raise their hand twice. The whole matrix circle is 48. If 10 of them are already placed here, then there must be 38 left. There's 42 kids in the vector circle, So there must be 32 here. Now, these numbers should add up to 80, because remember, everybody was supposed to be in there, and it does, it adds up to 80. We don't have anybody out here. Now, what was the question? How many like only vectors?
32.
That would be these guys right here, right? They like only vectors. So the answer would be 32. Okay? All right, number 7. How many committees of 5 Republicans and 3 Democrats can be chosen from a group of 10 and 7?
Five.
Well, it's a P problem, Kaylin, if order matters. It doesn't matter, does it? If I'm just picking people for a committee. So it's a C problem.
Five.
And Kaylin, can you give us more information? It's a C problem. What would it be? Let's pick our Republicans. Now, how many Republicans are there altogether? How many, no, not how many am I picking? There's 10 altogether, and how many of them am I picking? And order doesn't matter. So what would that be? Actually, always the big number first. So it's gonna be 10C5. There's my Republicans. There's 10 Republicans, I'm picking 5 of them. Everybody okay with that? Now, Kaylin, what else? And what am I gonna do with those since I am picking Republicans and Democrats?
Multiply.
Multiply. So then you'll type that in on your calculator, and you'll get 8,820. Remember, on the test, you have got to type it in and get an actual answer, okay? How many ways can 4 unruly students be lined up in the home? 4 factorial. 24. How many ways can I give 5 identical pencils to 5 different students in a class of 8? 8. Why are you saying 8C5, Katie? Because order doesn't matter. Order doesn't matter. Why does order not matter? Because the prizes are identical. If the prizes were different, then it would be 8P5. Maya.
So, are you going, is the 5 from the identical pencils or is the 5 from the different students?
Yeah, it's the same 5. 5 kids are, I have 5 pencils to give away, so 5 kids are gonna get the pencil. It's the same.
So it's total amount of people that you have.
And then I'm gonna pick 5 to give a present to.
Okay, and that's, the second number is like your selection of
Yep.
people.
Yep, yep. Some people look at this notation, Maya, and say 8, choose 5. All right, number 10. How many 10-letter words can be formed from the letters of a calculator? How do we start this? We start with 10 factorial. Kids, we start with 10 factorial because there's 10 letters in the word calculator, right? Okay, I need everybody's eyes open. Bryce, you won't fall asleep if you sit up.
I'm not following.
Oh, yeah, you are. Well, or maybe you're just daydreaming or something, but your eyes are shut. Yeah. Now, what do I do once I've got the 10 factorial figured out? Katie? So how many letters repeat? I've got 2 C's, so I'll divide by 2 factorial. I have 2 A's, so I'll divide by 2 factorial. And 2 L's, So I'll divide by another 2 factorial. Is that it? And when I type that into my calculator, let's type this one in, just make sure everybody can get it. Because I'm paranoid you're gonna type it wrong. Yep, anytime there's more than one thing in the bottom, you need parentheses. So I got 453600. See if you get that.
Do you have to say which letters they belong to?
No, I do that to keep track personally. All right, and the last question on this page. If it rains, if it doesn't rain, doing homework. Okay, when you look at this problem, what do you think? Tree diagram. And what's going to be first in the tree diagram? Your 2 options are homework and rain. Rain goes first because his probability of doing homework depends on whether it rains or not. So whatever doesn't depend on goes first. So what do we know about rain? There is a 10% chance and then a 90% chance it won't rain. So we are going to do homework or not do homework, right? All right, here we are. We're on the rain branch. It's raining. What's the probability he'll do his homework? 65? Now, what if it doesn't rain? 32 and 68? Now, what do we want to know? Probability he'll do his homework? You're going to find that in 2 places. You're going to find it right here, and you're going to find it right here. So you can do homework on this branch, or you can do homework on that branch. Now, how do I get this number here for this branch? What do I do? Multiply. So that would be 0.065. How do I do this one? Multiply. Can't do that in my head. I should be able to, but. There's my answer. Now, does anybody have a question about that? All right, what's next? Okay, now we're going to do an expansion problem. Okay? Julia, did you bring your Kleenex?
Can I bring it during lunch?
And Jabron, you didn't bring yours, and this is like your 8th warning. So I need the Kleenex, or I'm just writing your attention and we're moving on. Okay? Same you can bring it during lunch. So Jabron, you can bring it during lunch, or we'll just call it another detention.
Miss Ford. Quick question.
Yep.
My little my people in my group, they're up there on the first 2. Can I pay for their thing?
Of course you can.
She's trying to look the course.
It was good. It was actually really good. I wrote notes and everything. No big deal.
That's my fault.
It's okay, guys. Guess what? Yesterday I went to church. I didn't get struck by lightning or anything, walking in or anything. It was actually pretty nice. I'm not even gonna lie. And it was a nice, good-looking man in there too. So the water got
Oh, I love her.
What just happened? What actually just happened?
Sorry, the one that Dion's mom's birthday. That's okay.
Which one? Which one's supposed to go to? I can't wait. Which one? The one 3?
Yeah. I wasn't gonna go very far. I wasn't a kid here. It's like a day or something. You didn't go to one of the That's what I'm saying, that's what I was.
Okay, we're gonna expand this.
I think we just had a moment.
We're gonna expand this.
Yeah. Oh, yeah, yeah.
All right, here we go. Here we go. 3x minus y to the 5th power. We're going to expand this. Now, this one takes up more room. That's why you have more room. Step 1.
Draw your time.
Okay? We need numbers. And the numbers can come from Pascal's triangle. So I'm going to build this one more time. Tomorrow you are building it on your own. It is not on your test. So we start with a 1 and a 1. Then we put a 1 on each end like this. And then to get the inside numbers, you put it right between these two, add them together, you get 2. Now 1 and 1. Now put a number right here, it would be 3 because I'm adding, and another 3. 1 and 1. This would be 4. This one would be 6, and this one would be 4. When you're writing the row, you're putting the numbers in between the two above it, not underneath them, in between them. So 1, 1. This one would be 5, 10, 10, 5. There are your numbers. That's where you start. So 1, 5, 10, 10, 5, 1. Step 2. Step 2 is easy. Put in the things, Dane says. Each term is going to have 2 parentheses attached to it. And in those 2 parentheses, it's always 2 parentheses. And in those 2 parentheses will be, in this problem, 3x and negative y. The 2 parts of the problem. Step 3. No. First we have to put our powers on. And we're going to the 5th power. So the power on the first variable, which for us is 3x, will start out as 5. And then it goes down. And then the second variable does the same thing, but from the other end. Maya? What? It's emergency? All right, hurry up. Now, I always, for my own, I guess, security, put plus signs between my terms because they start to run together if I haven't been real careful. And I need to simplify each term individually. So I don't want to get things mixed up. So what have I got here in this first term? Remember, anything to the 0 power is just 1. So you really don't, sorry. You really don't need to worry about anything to the 0 power. This is going to be what? 243 x to the 5th. Remember that that exponent goes with everything inside the parentheses. 3 to the 5th. Next. Now be careful on this one. This term is actually going to be negative, isn't it? Everybody see that? We're going to have negative. Okay, be careful. It's 5 times 81 x to the 4th times negative y. Everybody see why that's 81? So that's going to be negative 405 x to the 4th y. Next, what do we got here? Got a 10. What's this term gonna be here?
Negative 27.
Actually, that's gonna be 27. Now, will this term be negative or positive? Positive, because we're squaring out the negative. So that'll be 270 x cubed y squared. Next. Will this one be positive or negative?
Negative.
This one's gonna be negative. Remember, when you raise a negative to an odd power, it's negative. What's this?
Negative 9.
That's 9x squared, so you got 9 times 10, that's 90 x squared y cubed. Xy to the 4th minus y to the 5th. Anybody have a question about a step to that problem? That takes a little more time than the other ones do. Now the next question then says, we need the third term of that expansion. Now really, groupies, you're going to do exactly what we did here, because what did we find here? We found 6 terms, right, of the expansion. We found them all. So this is actually a little easier. You don't need them all. You only need one of them, the third one. Now, remember how you built these terms? What did you start with? What did you find first? The number, the coefficient. Now, you could expand your triangle out to the 10th row, but that's going to take a long time. You can do it. I'm not going to do it. Who remembers how to find these numbers in a different way than building the triangle? Building the triangle is fine, but there's another way. The C numbers. So in the 10th row, the first number would be 10C10. What would the second number be? And the third one, 10C8. That's the one we want. We're finding the third term. The third term in the 10th row would be 10C8. What is 10C8? 45. So I'm going to start with the number 45. Now, just like this one, next to that number will be 2 parentheses. What will be in the parentheses this time? 2x and negative 3y. What's the third step? Put on the exponents. Now, in the first term, the power on the 2x would be 10. Here it would be 9. Here it is 8. If there's an 8 on the 2x, we're going to the 10th power. What has to be on my y? 2.
Why is it 2?
Because they have to add up to 10.
Oh.
Now, let's simplify. I've got 45. Okay, now wait a minute. What's 2 to the 8th?
256.
256 x to the 8th. What is negative 3y squared? 9y squared positive? So I have 45 times 256 times 9. The answer to the problem is 103,680 x to the 8th y squared. how can you calculate 8C5 by hand? Okay, this is a formula, you need to know it. How can we calculate 8C5 by hand? What's the formula? Always 8 factorial on the top, write that number right there on the top. And 5 factorial goes on the bottom along with 3 factorial. And the 3 factorial is just the difference. Now we're going to calculate that by hand. So we have 8, 7, 6, 5, 4, 3, 2, 1 over 5, 4, 3, 2, 1 times 3, 2, 1. Because that's what factorial means. What do you notice about this right here? That cancels. What's 3 times 2 times 1? So that cancels. The answer to the problem is just 8 times 7. That's all that's left. So it's 56. Okay, now you gotta answer some Venn diagram questions. Now, it'll be set up just like this on your test. So I'll have the Venn diagram drawn, I'll have the probabilities over here to the side. Where do you start? The middle. So in the middle is gonna go 0.51. Would you agree with me? Now the whole M is 0.62. So what's this? 0.11. The whole N is 0.75, so this would be 0.24. Now what do these add up to? These add up to 0.86, which isn't enough. What does that mean?
There's some on the outside.
There's some on the outside, and if these add up to 0.86, this would be 0.14 on the outside? Right? Because when it's a probability problem, they have to add up to 1, 100%. Now, what's the question is, this is the question. Now, what does that mean? What does all that symbolism there mean? What's the probability of being in M and not in N? So we want to be in M, but we don't want to be in N. So we must be right here, 0.11. What does the other question mean? What's the probability of not being in either one? That would be 0.14. Maya, was your hand up? Maya McClure?
Do you, how do you know, okay, what's the difference between that one and then the word problem that we did? You said that one has to add up to 100, but.
Well, because this is a probability question. Probability has to add up to 100%. The other one we did was that we had to add up to the total number of students in the room.
Oh, that's a.
Yeah. Okay, we're almost done. Let's see if we can get it done. Next page. We've seen this chart on every practice test, I think. I don't think it's changing. What is the probability? Okay, so here's the deal. Here are these classes. I'm going to reach in and grab a kid from each class. What's the probability they both like English best? What would that look like? Question A. 0.2 times 0.3. Does everybody see where she got these numbers? So that would be 0.06. Let me encourage you, since you're going to have a calculator, to do this on your calculator, because I'm afraid some of you are going to mess up the decimal places. Because you're picking an English and an English. You're picking an English and an English. What is the probability of the first one liking math and the second one liking art? Okay, first one math, 0.6. Second one art, 0.06 again is your answer. Neither will like science. They don't like science. Okay, what would be class 1? 0.9. That 0.9 is everybody except the science people, right?
Yeah.
Now, what would the next one be?
0.8.
That's 0.72. That's neither one being in the science group. One will like science and the other will like math. All right, one will like science and the other will like math. Okay, what's your thought on that? 0.1 times 0.4? We're not done. This is the probability of the first one liking science and the second one liking math. Is that what the question asked? No. What else could happen? We could have the first one liking math. Okay, this is science math. We could also be math science, couldn't we? So that would be 0.2, 0.12. So what is the answer to the question? We could be science math or math science. We're going to add these. So the answer is 0.16. Okay? Thomas, you're going to turn us off. I'm going to take attendance.